Da har jeg gleden av å ønske velkommen hit til et samtaleforum på cirka en time som har titelen Satellitter og klima. And because we do have people in the panel here who are not fluent in Norwegian by now, we'll switch to we'll have to switch to English. As you probably noticed, there's been some technical issues up here. I had prepared a beautiful background slide and some beautiful videos, but we'll just have to talk because we are not able to get it uploaded, actually. So then I think I will just mention that I do have a panel here. We're going to talk about space and climate and how space can assist in climate monitoring and mitigating. And from the left to the right in my panel here, I have Josef Aschbacher, General Director of the European Space Agency, ESA among friends. Bjørn Samset, you're a senior researcher at CICERO. Ole Morten Olsen, you're Director Earth Observation and Space Science at Norwegian Space Agency. And Tørres Jæger, you are actually the General Secretary of the Rainforest Foundation, Norway. So we are going to talk about how this data from space can be used, are used, and how they can be even more efficient in the years to come in working on climate issues and predicting and helping in climate work. We can take some questions afterwards, probably the last 10 minutes or so of the program. And Nora, she will be sitting there. And to all of you who are visiting or watching us online and stream, you're welcome. And if you have some questions, there is a chat in the YouTube video which can be used. Otherwise, just join us. I'll start with you, Josef Aschbacher. You are the director of European Space Agency, and that is an international organization with 22 member countries. Norway is one of those. And your visit here today is also a part of what you call ESA Days, which is an initiative from ESA to discuss and to communicate with the member countries. And the topic to communicate here today is space and climate. And you took up your office as Director General 1 year ago, and previously you used to be head of Earth observation in ESA, so this is sort of your home field. My first question is actually, it's an overwhelming one, but what is the most important contribution from space and satellites to climate and climate issues?
That's a big question indeed. So first of all, very happy to be here. It is today Space Day in Norway. We have these space days in different countries, and today it's Norway's day, so I'm very happy to be here. We had a very nice pre-meeting yesterday. We have a series of meetings today, and also see the minister a bit later on today, so it's a really important day for us. And looking at what in Norway space is doing for various applications. And of course, climate is a #1 topic in Norway and many other countries of ESA, the ESA member states. So how can space help in climate? Of course, this is something I really know well because I've been working on this for so many years. What we say is satellites are taking the pulse of our planet because they really look at all the components of the Earth system, the atmosphere, the oceans, the land surface, but even more, to understand how this works together. It's not that you only have the atmosphere, or only the oceans, or only the land. It's really an Earth system, and you have to understand how this works together. And you would know perfectly well that this is an integrated system which you really have to understand how it functions. And people think you know everything about our planet. No, we don't. There's still many things that we discover. I mean, the IPCC report, we have discussed it before. Every release is giving new information, new insights on the processes, but also the way how our climate behaves. So satellites play a crucial role in this. As probably you might explain in a minute, out of more than 50 so-called Earth climate, essential climate variables, more than half of them can either only be measured by satellites or predominantly by satellites, because the parameters are so difficult to measure otherwise. Take melting of the polar ice caps as an example, sea surface temperature, sea level heights, CO2 concentrations in the atmosphere, methane concentrations over the Russian Siberian area, and so on and so forth. So there are many parameters that influence climate or that determine climate, and satellites are the parameters that really measure those best, or the only ones, because you can't do it easily otherwise. So they are really essential, and they feed then into the IPCC reports, of course, to our general understanding of how climate develops, and it's a very important asset of it. But one thing, of course, is measuring. An even bigger challenge is to use this information for decision making, so to advise politicians, but also the general public, what happens and how can you do better. And there, the whole modeling aspect comes into play. So you have observations on one side, Earth system models on the other side. Of course, you need big computers, artificial intelligence, all the IT tools at your disposal in order to predict what might happen. And we call this the what-if scenarios. So what would happen if you change a parameter one way or another? In fact, there's a new program which, of course, we're developing since some time now, called Digital Twin Earth, where you want to simulate our Earth, our planet, digitally on a big computer, of course, a very big computer, to really help decision makers make decisions. What happens if you change one parameter? Look at rainforest as one of them. What would happen if you deforest the Amazon by 10–20%? What is the not only on climate, but on people? And I think this is the big challenge we see. Yeah.
But I think we have to take one step back. Because you talk about satellites and data. Actually, where are they? What do they measure? How is it transferred to Earth? What is the technical background of this? Do you want to answer, or shall I put that to Ole Morten Olsen? Can you answer that, Ole Morten?
I can try to answer that. Climate is a global issue, and you have to cover the whole globe. So because of that, most of the climate-related satellites are polar orbiting satellites. So they are scanning the whole Earth, and because they are polar orbiting, they are also scanning the poles of the Earth much more often than close to the equator. And that means they get a lot of data, especially in our part of the world. And we know that climate is the influence of climate change is especially high in the north. We see it in temperatures, for example, on Svalbard, that it's much higher than average. So satellites are important. And we have a satellite station in Norway also, so there are a lot of this data from the European space programs are downloaded in Norway. So we are participating also to get this data to the global community through Norway.
And we're talking about satellites from this size to that size, in orbits from 500–600 kilometers above the Earth to 900 approximately. And Bjørn Samset, you've been using a lot of this data being downloaded. What particularly are you interested in when it comes to what satellites can measure?
Basically everything. I mean, that's the fun thing about climate science, right? You can do this whole overview over the whole climate system. That's what satellites give us. So I was part of writing this, the first part of the previous IPCC report, the one on the physical changes in the climate system. And one of the things that we did there was to, in addition to all this new science, we also assessed the history of climate science. And there's, of course, an explosion of knowledge around about 1980. Why is that? Well, that is the advent of the satellite era. That is when you start to get all these various measurements, as the Director General has already listed. I mean, it's everything from temperature, precipitation, ice, forest smoke. I mean, whatever you can imagine in the climate system, you can see from above. So that's the first usage. You wanted to use it to just understand all the processes that go on around us, because though we are many people, we aren't that many scientists, so we don't see everything that's going on. Satellites can see everything for us. And across this Working Group 1 report, we actually cite usage of over 100 satellite products alone, and they're used in every chapter of that, so they're absolutely crucial for the information. Then, of course, the second part is the long-term observations to see how things change over time. So first is to learn how the system works, then how it changes over time. This would be interesting in its own right, but of course now that we have climate change and very rapid climate change going on, we need to be forewarned. We need to know what is happening and how fast things are changing, also in places where we might not expect a change, and that is monitoring that satellites can give us. In Norway, we've worked a lot on short-lived climate forcers, so things that are not greenhouse gases that when you emit them, they stay in the atmosphere or they change the climate for hundreds of years. But say you light a forest fire, or you have a coal-fired power plant that emits sulfate. This becomes smoke, particles that stay in the atmosphere for only a few days, but they have a very strong influence on the climate when they are there. Where do the particles go after you've fired them, or after they've emitted from the coal-fired power plant, or after your forest fire? That has a lot to say for the downwind climate, but we cannot see that just with our eyes, and it's very difficult to have enough ground stations. So that is something that satellites really can tell us. And that, as the last point, leads us into the future, because we know that there are massive changes going on. We know that we will have to mitigate emissions, and we know that we'll have to adapt to climate change. I mean, both those aspects, satellite information, will be absolutely crucial. On the one hand, for tracking the changes in emissions. One thing is that the satellites will be able to tell us whether we actually cut emissions. We will be able to see that in many ways, because you will see the reduction in coal selling, buying, for instance. But also you will be able to see the response of the biosphere. So is the biosphere still taking up carbon? Are the oceans taking up more or less carbon as the Earth warms? We actually do not know that yet, so that would be a crucial information. And then there is climate adaptation, so reducing, mitigating climate risk. If you have observations that, well, the obvious big example is if you're about to be hit by a massive storm, you have to know it, right? Then you can evacuate people. But there are all these smaller effects still, like heat waves, emerging urban heat islands, things where if you know in advance, then you can prepare, you can evacuate if necessary, you can pull in more water if you know that will be necessary, you know if an agricultural issue is coming up. So it's also monitoring for adaptation to increased climate risk. Satellites are important across the board. We will need them, and we will need this continuous monitoring.
Thank you. Tore Seger, you are sort of more like one of those important users that the satellite data are meant for. You're General Secretary of the Rainforest Foundation. To me, that is a totally different area than for instance, what Bjørn is talking about now. He's talking about ice loss and measuring CO2 and so on. How can you make use of satellite data?
I think it's more of a that we're sort of on a span, and maybe I'm really more on the user side. But the Rainforest Foundation Norway last year published the State of the Rainforest, and that was sort of the first of its kind. And what was interesting about that was that before that we had a lot of conflicting data, assumptions, opinions, and now we, for the first time, were able to actually give an evidence base to what is rainforest, where is it, what's the extent, where is deforestation, how much has been deforested and how much has been degraded. So we now know that a third of the world rainforest is still intact, 1/3 has been deforested, and 1/3 is degraded. And that sort of simple evidence base, to just have a knowledge base to sort of also then make decisions out of that, we didn't have to that scale before. So that's one important use. But two others are also we can monitor commercial activity, so we know where rainforest is being taken down for soy, for palm oil, for cattle. And the third is that, for me, I've not been in the Rainforest Foundation so long. It was interesting to learn that, in the sense, the Rainforest Foundation was based on an assumption, and the assumption was that indigenous people are best placed to protect their habitat. That was an assumption. It was sort of evidence on the ground there and there. And now we can look at that at scale, looking at satellite data, and can have an evidence base for being able to say that indigenous people, when they're given rights over their territories, are able to protect their territories in better ways than other forms of conservation. And that has a very direct impact. If we look at the COP26 in Glasgow, one of sort of the breakthrough moments was the recognition of indigenous people's rights and their stewardship of forests as a means in
there in Norway, and you make a report and you use this data. Are they available for those who actually are in the rainforest? Can they use it in one way or another?
I think that's the great change that we've seen, is the availability of data. So both availability and making it usable for organizations like us. So it's not only that you get satellite images, but that sort of the data that are contained in them are made accessible to organizations like us, such that we can both make an analysis that is relevant. And yes, our partners in rainforest countries make active use. They have a type watchdog function, so they can actually monitor from day to day on where activities are happening, and we can use it more sort of systematically to generate trends that develop over time.
Please.
I think, as you say, availability is a key issue, and it starts, of course, on the data collection. And some people may, or not everyone may know, that that Europe is leading in terms of observation from space. There are huge programs that we have put together. One of them is Copernicus. It's not only Copernicus, we have Earth Explorers and other missions as well, but the Copernicus program certainly is the gold standard of providing data for the various applications, for forestry, for climate, and so on. But I think one of the most important success criteria of why Copernicus is the gold standard is because we have been fighting for a free and open data policy. And this was done in around 2010. I've been also myself driving this discussion a lot. And we have really been insisting that we have a free and open data policy. That means all the data from these satellites are available to anyone in the world for all kinds of activities. And that, of course, makes a huge difference, because that makes it very transparent, and people can really make good use of these investments, which are done by the countries collectively. And today, Copernicus is the biggest supplier of data in any space domain. 300 terabytes of data every single day are disseminated throughout the world. For forest monitoring, for climate monitoring, for agriculture, for disaster management, for all kinds of applications. And I have to say that this is really decisions made by member states collectively, both on the EU side and the ESA side. But ESA was the first one to propose this data policy. I really have to say that the member states have been extremely forward-looking and very clear what they want. And maybe a last word on this. This was not the practice 10 years ago. 10 years ago, data were very restricted. Models have been discussed of selling them, protecting them only for limited users, European scientists or European. I mean, that doesn't work. And this was a big discussion at the time. Took some years, but I'm very happy about this. And I think this is helping projects like the ones we see here, which make it possible that we really understand our planet and really can use it for climate monitoring.
Morten Olsen, please.
Yeah, and also Norway, we try to contribute some of the gaps which are there with the data from Copernicus. So 2 years ago, the Norwegian Ministry of Climate and Environment, they put out a contract where they bought a lot of commercial optical data with higher resolution than you can get through the Copernicus system, and that's also free and open. And that has been a great success. So within 1.5 years, they have more than 10,000 registered users, and the users are from more than 100 countries in the world.
In fact, Norway is a bit of a pioneer on the use of these data. As you say, commercial data, which you have made open for your purpose of your country, and also obviously the Copernicus data, but you also have huge national projects where you use them systematically for important applications. There's a project which Norway was the first one to use all the radar data, Central One data in particular, for subsidy measurements, so changes of heights of at the surface, of buildings, of rocks, landslides, and this type of thing you can measure at the accuracy of millimeters. And this is really quite significant. And Norway is a pioneer on many of these things, not to mention maritime security, fisheries, Arctic monitoring, where historically Norway was very active.
I'd like to ask you, Bjørn Samset, because you're sort of you've been working on this satellite data for almost decades. Sounds like you're immensely old, but you're not.
Not personally for decades, but yes.
But connecting to what Aschbacher said, the release of data, getting a free and open data policy, how did that impact science?
Oh, it's absolutely crucial. I mean, it means. I mean, science is now an international endeavor. It's not individual geniuses sitting in offices thinking things up. I mean, you have to have many people and a lot of information from different sources to track now all the global evolution, and that cannot just be restricted to whomever happens to have the money to send up a satellite. Then you will not get the information. Example of that recently was when we had this, shall we call it, unintended climate experiment, when all the world went into lockdown almost overnight. Now, none of us wanted that situation, but in April 2020, everyone just went home and closed their doors for pandemic reasons, which of course had huge impacts for emissions and for air quality. And that was an experiment no one had planned for. But it was monitored because we had satellites, we had also ground stations, there were flights still going, so there was all this information, and it was available to scientists real time, which means that we could immediately track the effects that this had on local air quality, changes in cities. In some places, a reduction in emissions meant that air quality became worse because of chemistry reactions that you could maybe have predicted, but you certainly didn't have the information available to fully understand how that would impact the ozone conditions at the surface. And also the effects that this had on temperature, on precipitation, very difficult to eke out, but since you have the information available, you were able to see the early signs, and then you could guide the scientific process towards that and be able to kind of to focus on the right things, to get these signals while things were happening. So you could see the dynamical evolution, and a lot of good science came out from that already.
Just ask you, Thais, if the use of satellite data can be used as a political pressure, do you use it that way?
Absolutely. And the beauty of it is that it's data, it's knowledge, it's evidence. So it's not opinion based, if you wish. And I think that is a major factor in both our credibility and our partners' credibility in being able to articulate the real dangers in terms of deforestation, in terms of encroachment, in terms of illegal activities, is that you can actually not only articulate that it's happening, but you can say where it's happening. And we've seen, I mean, we see both, of course, but we have seen also authorities being triggered into action and being triggered into action basically in real time in response to reports of, say, illegal activities that go on. So it can, that's not always the case, of course, but there is an evidence base that is sort of undisputable, and that makes it very difficult for authorities to disregard the information that we're bringing to the fore.
Yes.
No, I think fully agree. But maybe one aspect we have to, and which of course keeps me busy quite a bit, is when we put these programs together for the use of satellites for climate monitoring or monitoring of our planet. Of course, climate is a key issue, but then you have other, day news of the war in Ukraine being the news item today. We have to be very careful not to lose focus on the climate issues, that they will stay. Climate change is an issue. Of course, we all are very concerned about security, protecting the security of our people and our citizens, and again, space can also play a role there. But just to underline, do not lower your guards on the climate monitoring aspect, because that problem will stay. That will get even worse every month and every year. And this is something, of course, I need to look into when we put programs together for our member states to fund the next phase. I mentioned Copernicus before as a big one. We have to keep insisting on this and not neglecting or ignoring it, despite all the things that happen in the world. So I think this is something that is crucial, that we do continue these measurements. We do not get distracted by other events. Of course, don't misunderstand. We have to focus on those as well, but the baseline issues are always there on our table.
No, I absolutely agree. And the real strength, of course, in the satellites now is that we have observations since the 80s. We can track a number of these variables over time in a way that we can't do elsewhere. That was also something that was highlighted in the last IPCC report. It was the danger of loss of even short time periods in these continuous observations, or discontinuities between satellites and measuring systems that will set us back immensely. And also other developments, like we are dependent on, for instance, for observations of water vapor. There are some frequencies that you're dependent on seeing, and those frequencies are some of the same that are used by the 5G system, which makes noise.
So we actually compete
Exactly.
about the frequencies.
Yes, so I mean other in a sense positive developments can also encroach on the ability of satellites and other measurement systems to do their job.
But where is that disagreement decided upon? Who will win war on frequencies?
And that's a huge process. These frequency allocations are done at the ITU, which is International Telecommunications Union. It's a UN body. And as Björn is saying, there are different interest groups debating, and they come together, represented by the member states, and the member states then make the decisions. And in fact, what you are referring to is the 23, 25 gigahertz range, which is a very crucial one for Earth observation, but also for telecommunications. And these interests, of course, are competing against each other, and the decisions are made there.
And the frequencies are used for actually transmitting data?
Exactly, yeah.
So if you don't
both
have
for measuring and for transmitting.
And if you don't have them, then you can have as many satellites as you want to, because you're not getting any results.
It's not so black and white, because there are other frequency areas which you can use, but they don't have the same quality. I don't want to go into details, but this one is particularly interesting because it is close to a water absorption band, and therefore it allows you to retrieve information of water content in the atmosphere. If you don't have this band, or if it is disturbed, then you need to use another band, but that's different technologies and so on. So it's not black and white, but of course these are limitations.
Yeah, so also the frequency band is in some way a natural resource.
It's
where people are fighting because there is not, everyone can't get what they want in the future because it's a restricted resource. And some of them also has to be protected so the satellites can be used for monitoring the climate and give the input needed to the scientists and for the preservation of the Earth and the climate.
We've been talking about European space programs, but how is the situation in the world? Who are delivering data in? What countries are important? Do we cooperate? Yeah, what about United States, Russia, China, Japan? How is it on the global scene, so to say? Who's delivering in all this data that we need?
I think the big players are certainly Europe, and I said before that we have the gold standard with the Copernicus program. And something that is quite unusual, in the Copernicus program, NASA is a junior partner. Normally we are the junior partner to NASA programs, but in this case it's the other way around, because we have the world's best Earth observation program at the moment. And this, of course, takes time to build it up, but Europe is in a very good position there. So Europe certainly is, I would say, the reference today in providing this data for climate monitoring. Of course, NASA and the US are another very important data supplier. I will sign an agreement with NASA in June with the head of NASA, the NASA Administrator, Bill Nelson, the June Council, when he comes to visit Europe and speaks to our council, on Earth observation. So the use of Earth observation data of NASA assets, NASA satellites, and European satellites, and how we can really combine them. And I want to be modest, but I think if you put together the NASA and the ESA satellites and Earth observation, you probably have 3/4 of the global data sets available, or maybe even more than that, which are used and useful for this purpose. So I think these are really the two key pillars in terms of data supply. Of course, you have China, but China has a very different data policy. It's not so easy to access them. I've been visiting them just before the pandemic 2 years ago, trying to have a data exchange agreement with them. They have a series of Gaofen satellites, as they call them, and which is a bit a replica of our Copernicus satellites, not as advanced, but certainly similar in terms of characteristics. But it's difficult to exchange data. We have not managed to have a significant data exchange program established. So they do provide data, but not as easily accessible to the international community. And then, of course, Japan is a good partner with whom we exchange a lot, but they have very few satellites. And then you have a few others, of course, India and so on. But one new, Russia, almost nothing, and the civilian Earth observation part. But one new source of data that comes now more and more onto the surface is commercial data suppliers. We call it sometimes new space suppliers, but also the more established ones. And this is something I really want to develop also in Europe, because, of course, you have the institutional data suppliers, like the Copernicus data, but this commercial sector develops very fast and very rapidly. And there I really want to make sure that we develop, as public entity, commercial suppliers where we don't develop the satellite, but we buy their data according to certain standards and criteria, because they can do it well. They are very fast, dynamic, and they develop their constellations. And I really would like to establish an ecosystem of suppliers in Europe of these data. And actually, Norway has some small satellites, not necessarily of the same, I would say, commercially driven. There's certainly a government interest behind, but this type of satellites I really would like to integrate into a holistic system, which is, we call it a hybrid system of the more established ones, the Sentinels in particular, and these newer satellites that come in, mostly a bit smaller than the reference satellites, but very useful because they really complement these measurements. And this, for me, is the next big development in terms of data collection, to integrate big and small, sometimes I call it, or new space and the more historic data. And that really allows you to have frequent measurements on one side and more reference, highly accurate measurements on the other side. And the combination is very powerful. But this has yet to happen. It's not yet fully implemented.
But the game is still to have a free and open data policy, in spite of not ESA or EU delivering all the data themselves.
Absolutely, yeah. Absolutely, yeah.
Okay. Björn, I would like to ask you, because you were the lead author of the report that came in August. What is the status now concerning climate and development. Try to be optimistic.
Well, change is always potential for something positive, I guess. Everything is changing, right? That is really the short and the long answer. Wherever we look in the climate system, everything is changing. That is from the top of the atmosphere down to the bottom of the oceans. And we know that now because we have these longer-term measurements, both from the ground and from satellites and everywhere. But you can't just view the Earth for a couple of years in one way and say you have an understanding, because there's so much noise. There's all the weather system. There's all these natural processes. If you want to track these longer-term changes that are extremely rapid on a geophysical time scale, but still very slow on a human time scale, you need these continuous measurements. And the thing now is that, of course, we have seen, if you will, the Earth through a very stable period, the Holocene. There hasn't really been any major changes other than volcanic eruptions and these kind of rapid things for thousands of years. You've had regional changes like the Ice Age and the medieval warm periods, but they were local. Now things are evolving beyond what we have any experience with. Of course, it's getting warmer, but that which brings with it some heat waves and all that, but it also changes the whole structure of the atmosphere, so the whole circulation system, the whole evaporation, where it rains, where it's dry, how heavy it rains. The biosphere is reacting to this. The ocean and the biosphere are both carbon sinks at the moment. It may not remain so. There are changes in the ocean systems that are difficult to track. So it is more and more crucial that we have a full and complete overview of all the rapid changes, because we do not know where the geophysical system will really start to change rapidly. That is just a key unknown that we just have to accept. We can think we know, because we have a pretty good overview, but we also know that and science. There are papers saying this, that the only certainty is that we will be surprised by what is coming. The satellites, of course, they're our bread and butter. It's absolutely crucial that we have this monitoring.
Yeah. And I think what Bjørn is also hinting at are these tipping points, that some elements in our cycle, take the famous Gulf Stream as a famous example, where early indications need to be understood in order to see what happens or what might happen. And if that happens, I mean, if the Gulf Stream would cease to transport heat from Florida to Norway, the climate in Europe would be very, very different, and the situation in Europe would be very different. I hope it's not happening anytime soon, but these are huge dangers. Yeah?
Well, just to wrap it, that is certainly true. I mean, the tipping points, that's kind of the big bad wolf, if you will. That may certainly happen. The assessment of the IPCC report was that we do not think we're near the thresholds of any major tipping points, but of course that is an unknown. We haven't been in this territory. But there are also other rapid changes, like rapid changes in the biosphere, migration of species, rapid shifts in the areas where you see forest fires, for instance. So the encroachment of forest fires into boreal forests in Siberia. That is something that is difficult to track, because you don't have people on the ground in all these places, but you can see them from space. So these are also very rapid changes that could maybe have been foreseen, but they're certainly much more easy to detect and to track when you have the view from space. Yeah.
But would you say that space data is sort of being transformed from being something that made you look back and make long time series and to confirm your models into something that is more hands-on? And in what way?
Well, certainly. I mean, climate monitoring and disaster risk preparedness is becoming much more operationalized. Right? If the climate was not changing, you would still have a risk of extreme weather, and that we've always had. I mean, you always had the weather reports in Norway with your specific storm warnings for the fishing boats and all that. That would, of course, always continue. But in the advent of more and more extreme weather, and more combined events, like, I mean, you have a drought in one area which impacts agriculture, and then if you have it was difficult to think of an example, but you have these compound events where one or two or three things happen at once. Of course, you need an operational climate risk monitoring. And that is also something you get then from I should say satellites, obviously, but satellites jointly with surface-based observations and with reanalysis systems, which is, of course, weather monitoring or weather forecasting, but where you use the information you have both from space and from the Earth to kind of fill in the gaps, if you will, because not even satellites see everything all the time. So that's yes, it's becoming more operationalized.
If you, Terje, could make a wish when it comes to the satellites and the data you need, what would that be?
Well, I'm not a natural scientist, so be careful. I think there are a couple of things. One, politically, one of the big elements that we're talking about is in connection to the climate and biodiversity crisis is both climate financing and ecosystem services financing. And for that, we will need data, reliable data at scale over time, such that we can actually sort of, if money sort of maybe from commercial actors is invested in climate financing, that there is a reliable system that actually is evidence-based and can tell that the money invested contributes as it states it contributes. If you, I don't know, if you buy a plane ticket today, you can, you can invest in your carbon neutral program. How do you actually know that that materializes, right? So how do you can we have a system that is reliable and that is evidence-based and that provides sort of the reliability that commercial actors also will need to be able to and governments and authorities and so on, to be able to reliably say this is the effect and this is the CO2 that has been absorbed or stored through different systems. I think that at scale, reliability, that would be one important element. And the same for ecosystem services. Our ability to value ecosystem services through precise measurements, I think, so the precipitation generated by the rainforest, such that you can, if we want, I don't want to be too simplistic, especially on this planet, but on this panel. But rainforest that is more worth that is being maintained than rainforest that is being cut down. That's at the end of the day. That's going to be the make or break in deforestation rates. So for that, we need to be able to make calculations, investment calculations, where you can take a long-term perspective into consideration, and where investors can look at, okay, yes, there may be a short-term gain for a cattle farm to go into rainforest and cut it down and raise cattle, but if that in the long term actually destroys the investment because you destroy the ecosystem services that come from a system like the rainforest, then the investment climate changes. And I think that is an important element, because we can have what we're seeing also, if in terms of politics, we can have all the sort of drama around deforestation in Brazil. As long as money goes into the country and finances deforestation, there is no political need to change that. So we need to be able to to change the underlying sort of incentive structure that allows for rainforests to be maintained rather than to be degraded or deforested. And for that, we need the data also for those investors to be able to make those calculations.
Looking forward and taking your wishes into account, Europe is planning ahead concerning new satellites. Will those satellites be able to sort of meet some of his wishes, or are we talking about a system which is way more complicated than just putting in data?
I think what you say, I really liked your assessment of the underlying economic factors, because that's at the end of the day what makes big decisions. If there's money flowing in, then people behave one way or another. And what I really would like to see, and this is actually a project we are starting now, is, I mentioned it before, the digital twin of our planet, which really is a coherent system of not only the satellite data, they are certainly an important source we can provide from that side, but mixed with Earth system models, with socioeconomic data, with societal data, and really see what are the implications, what does it mean for people, for investments, for people. I take another, forest is a very good example, and I think you have highlighted that one. Let me take another example, which is more related to food security. Again, a topic very relevant today, but food security not only in Ukraine or Russia or in the eastern part of Europe, but also in Africa. If there's climate change happening as we see it, what does it mean for food security in many parts of Africa? What does it mean in terms of migration, of regional conflicts, access to water, migration into Europe, political, and that has implications at big political level at the level of the European Union or countries like Norway. And I think this integration of space technology with all the other technologies and sciences leads us to help us to understand, to predict, to have these what-if scenarios, and therefore make, hopefully, at some point, better decisions. Then you may say, yes, you have all this knowledge and still people are doing stupid things. Yes, it's absolutely true. But at least on one side, no, it's a fact. But on one side, at least you understand what happens and what the impacts are, and hopefully the collective wisdom of people, one way or another, will help to make better decisions. So I think this is something that is really important to me. And since we are in Norway, let me really say that Norway is actually really quite active and the leading country in many respects. I see it in the European context and also internationally. The focus on forests, on tropical forests, for me is quite unique. For a country like Norway, maybe a bit unusual, but I think very laudable and very good. But also the Arctic. Norway has a very good understanding of the Arctic and a monitoring system in place from space, from ground, and also related to security. So I think Norway has a lot to offer there. To the international community, and that's something, of course, in the space part, I'm discussing with the Norwegian Space Agency. I'm very happy to have Christian here with us to see what does it mean in terms of space. How can space contribute to these wider questions? And I think this is something I'm really, first of all, very happy to see that Norway is such an active country, but of course we have proposals coming up for the future, and of course hope for very strong continued strong Norwegian support.
Well, Morten, could you say something about Norwegian ambitions outside tropical forests?
Yeah, so Norway, since we are part of the European Space Programs, that's the backbone of what we are doing and what we are thinking. But there is also another initiative from Norway, which is related to the global situation and things where Norway can contribute, and that's related to illegal fisheries. And Norway, we became ESA member in '87. That was partly because of ERS-1, which we started from day one to use for monitoring of ship traffic along the coast. So we started to use satellites for monitoring ships and fisheries very early, and we think that's something which will be useful both for countries around the world, but also for the global food security situation.
I think I'd like you Nora, to give us a question. I think there is one from the streaming audience.
Yes, we have a question from Lasse Pettersson. He asks, how much of the 300 terabyte of data per day are used for climate and other applications? And are the resources and technology to efficiently use these data adequate?
I think this is for you.
Yes, very, very happy. Yeah. The Copernicus data, for those who know the satellite lineup, the satellites that measure these parameters, they are, to a large extent, monitoring the state of our planet at a scale which is relevant for climate. If I would say that 100%, this is certainly exaggerated, but I would say the majority of these data are used for climate-relevant applications. And this goes in all domains, from agriculture to forestry to atmospheric chemistry. That means concentrations of CO2 or methane or NOx and many other gases. So a lot really is geared towards, and climate has been the main driver of defining the Copernicus system, climate questions, and really globally from the Arctic all the way down to the tropics, and it's a good portion of this. I cannot give you a number if you ask for a number, but the large majority of these data are used for climate-relevant information.
I'm looking at the audience. Are there any questions? Yes, from the woman on the third row.
Hi, my name is Jenny Bredin from the Norwegian Institute of Nature Research. And I've heard you talk a little bit implicitly about the importance of the biosphere and on-ground observations. And I would like you to make, or I'm challenging you to make that very explicit, the importance on-the-ground observations, of species observations, of forest structure, of the biodiversity in the seas and on land for the quality of what you can make of space satellite data. And I would also like you to elaborate a little bit on the challenges, especially for tropical forests, where satellites are not necessarily maybe the best source of data because of one of the most important climate gases we have, water vapor. Thank you.
To whom? Should I start? Yeah.
Yes.
Okay, biodiversity, of course, is linked with land use, land cover, or in the oceans, of obviously the use of the oceans, the quality of water in the oceans. And these are the main parameters which are really driving many of the biodiversity assessments. I'm not the expert in biodiversity as such, but I can tell you the land use, land cover changes, which are monitored over decades, are having a huge impact on all aspects of biodiversity. But also water, wetlands, availability of water, obviously the land cover itself, whether it's forest or agriculture or bare land or whatever. So these are all parameters that determine the wildlife or the biodiversity at large. So and the same applies in the oceans with water quality, ocean waves monitoring, ocean temperature, sea surface temperature, which of course on the fronts of cold and hot areas, you find fish swarms and so on. So there's a lot of information that you get from there. Of course, when you ask now, can you count the number of birds migrating from one country to the other? No, we can't. This is not possible, at least not from space. But the information of the living space of the species certainly is where space plays a huge role. And in fact, even goes to the point that people are making connections of degradation of biodiversity because of land cover changes, drastic land cover changes, with global pandemics. I mean, we all know some of the theories where how the COVID virus probably came from animals to people, because their living space has been squeezed due to deforestation, due to change of biodiversity, and therefore the jump from animals into humans is much easier because simply the fronts are getting much more stressed and much closer. So there's a lot of, as I say, I'm not the expert on wildlife and certainly not on pandemics, but certainly the monitoring of the environment is crucial to understand better the situation.
Yeah. Björn, I think.
Yeah, I mean, it mostly just confirm it. I mean, this is really the prototype is where you have the expression from, right? From bottom up versus top down. I mean, there's all these things you can see from top down, and the broad changes of the biosphere. But what drives these changes? There are many new satellite products now that I know that I don't have detailed knowledge of, but that I know that can really tell you about the processes that goes on with the changes in photosynthesis, changes in leaf cover. I mean, all these things that are driven by something, and that is not just temperature or precip. It's really the biodiversity on the ground, and in a sense that tells you about a change. But you have to have these local measurements to know what is actually going on. So say the beetle population that is part of increasing forest fires, because you have drought, you have an increase in bark beetles. What's that in English? Anyways, they're killing trees. That's one process you would never see from space, but you can see the effects from space. So that's just one example of where that was actually one of the things I was going to try and bring up at the end. I mean, yes, you have to have increased coverage of spaceborne instruments, but they always have to be designed jointly with ground-based measurements. That goes for biodiversity, it goes for short-lived climate forces, it goes for many other observables.
So I forgot to address one point you raised on water vapor. I fully agree, water vapor is crucial for everything. It's difficult to measure, you're absolutely right. But there are instruments that do that. It's the meteorological satellites, both the polar orbiting and the geostationary ones, that give you at least a good estimate at global level. And of course, with that, you have to feed then the numerical weather prediction models with ground-based measurements, radius-on measurements, an integration of all the measurements you get. But today, for weather forecasts, just to say whether it rains today or not, 80% of the data come from space, simply because they are measuring almost all the elements of it.
I think we're running out of time, unfortunately. And actually, I think the Beatles are a good way of finishing this, because it's all about the Earth. No matter how much you actually monitor from space, we are living here, and the help from space will increase in importance. So, by those few words, I'd like to thank Tørres Jæger, Ole Morten Olsen, Bjørn Halvard Samset, and Josef Aschbacher from the space and environment community. I think we should give them a big applause. And thank you for joining us here today in person and for joining us online. And I wish everybody a beautiful day with or without rain. So thank you so much.